This is the video for 6.2, inverse trig functions. In this video, I'm going to go over the differentiation or our derivatives for inverse trig. If you need a refresher on inverse trig, there's a video already posted in Canvas for you to watch that goes through examples 1 through 6. I'm going to go through examples 1 through 10. So we're going to differentiate. We're going to take derivatives of inverse trig. And just as a little reminder is that this arc sine is our sine, it's a -1. It's just right, it's going to get messy if I leave it sine to the -1 power. That inverse, like we're used to pushing on our calculator. So that's why we write it as arc sine, arc tangent, arc cosine. Okay. Just so that we don't start confusing things or think we have inverses or stuff like that. Or not inverses, like to the -1 power and try and put it in the denominator or anything like that. Okay. So the derivative of arc sine is 1 over the square root of 1 minus x squared. Okay. If I have some function of x, then it's u prime over 1 minus u squared. So I have to take that little hook piece there. Okay. With arc cosine, it's just a negative version. And then arc tangent, we get u prime over 1 plus u squared. So it doesn't have a square root in it. So we're going to differentiate my arc tangent of 2y minus 1. So, right, my u in this case is that 2y minus 1. So my u prime is going to be a 2. So we're going to write this, my g prime of y equals my u prime over 1 plus my u squared. Okay, we're done. I would not multiply out 2y minus 1. I would not FOIL it. I would leave it. Don't make yourself do more work than you need to. Okay. For example 8, I've got arc sine of the square root of x. So my u is that square root of x, or x to the 1/2. So my u prime is going to be 1/2 x to the -1/2. So take our derivative at maybe f prime of x equals my u prime, so 1/2 x to the -1/2, all over the square root of 1, so it's minus our u, so x to the 1/2 squared. This looks kind of jumbled, so we're going to simplify it. So that 1/2 can come down, and I have an x to the -1/2, so we can bring that down too. So 2 times the square root of x, right? That 1/2 power is the square root. And then times this other square root that was already in the denominator, which is 1 minus, and then x to the 1/2 squared just gives me x. And there's my derivative. So now it's 1 over 2 square root x times the square root of 1 minus x. Okay. Number 9, h of t equals arc cosine of the natural log of t. So my u is the natural log of t. That derivative, right, my u prime is 1 over t. So our whole derivative is going to equal 1 over t, negative 1 over t, over the square root of 1 minus the natural log of t squared. You could simplify this if you wanted, so -1 over t times the square root of 1 minus natural log of t squared. That's kind of your choice. Okay, number 10. y equals arc sine of x over 2, and it says simplified, so we want to get it simplified as possible. So RU is 1/2 x. RU prime is going to be 1/2. So y prime is equal to 1/2 over the square root of 1 minus 1/2 x squared. So we'll simplify. I can rewrite that 1/2 as 1 over 2 times this. Inside that radical, 1/2 x squared gives me a 1/4 x squared. Okay. And here's where kind of the math simplifying comes in. I can pull this 2 that's out front, and I can put it in there by essentially squaring it. Okay. So I'm putting it back under that square root. So 1 over the square root. If I pull in a 2, that makes it a 4 in that radical. So I get 4 minus x squared. And that is my simplified version. Okay, so that is differentiating inverse trig. So now go watch the next video about integration.